Okay, so we're doing module 13 of Introduction to Networks, which is ICMP. Of course, ICMP stands for Internet Control Message Protocol. So we're going to look at how ICMP is used to test network connectivity. It actually has lots of other jobs as well. And we're also going to look at ping and traceroute, which are actually part of ICMP. Now, oh, come on. And so ICMP messages. So Internet Control Message Protocol provides feedback about issues related to the processing of IP packets under certain conditions. And so ICMP version 4, funnily enough, is for IP version 4, and ICMP version 6 is, of course, for IP version 6. And so it does have some extra functionality in version 6 because some of the broadcast messages have sort of been taken away, and the multicasting modern equivalents are actually part of ICMP now. So ICMP messages common to both host reachability, destination and service reachability, and then time exceeded messages. And so ICMP version 4 messages are not required and are often not allowed within a network for security reasons. And so things like ping, while nice for testing connectivity, are also wonderful for a hacker to actually do a bit of reconnaissance on what IP addresses will respond and things like that. So yeah, it's often a double-edged sword. A nice functionality can maybe open you up to other things, sadly. It's always a battle against the hackers. So with host reachability, basically, have we all done a ping message? So of course, ping is basically when you type ping in the destination, your machine actually sends out an echo request. And so basically, you send out an echo request to the destination, and then the reply is an echo reply. And so the local host sends an echo request to a host. If the host is available, the destination responds with an echo reply. And again, that organization's security policy might actually block the echo reply from being sent, either at the firewall or on the actual host itself. Okay, so destination or service unreachable. So an ICMP destination unreachable message can be used to notify the source that a destination or service is unreachable. So the ICMP message will include a code indicating why the packet could not be delivered. And so a few destination unreachable codes are 0. The destination network can't be found. Code 1 means that the actual host can't be found. Code 2 means the protocol is unreachable, and code 3 is the port is unreachable. And so that's IPv4. And so basically, they've sort of renamed the codes a little bit. So 0 is no route to destination. So again, means the same as net unreachable. 1, communication with the destination is administratively prohibited. And so basically, yeah, it's been blocked by a firewall. Beyond the scope of the source address unreachable, port unreachable are the codes. So they've repurposed them a little bit, and they've also given them a bit more useful code name as well. Okay, so time exceeded. When the time to live field in a packet is decremented to 0, an ICMP version 4 time exceeded message will be sent to the source host. ICMP version 6 also sends time exceeded messages. Instead of it being the TTL field, it uses the hot limit field, but end result is exactly the same thing. And so note the time exceeded messages are used in Traceroute. Have I explained that in the past, haven't I? Yeah. Okay, so ICMP version 6 has new features and improved functionality not found in version 4, including 4 new protocols as part of the neighbor discovery protocol sort of set. And so we have mentioned these in the past, and I think we mentioned them in the last chapter, is messaging an IPv6 router and an IPv6 device, including dynamic address allocation, are as follows. And so when IPv6 host boots and it's set to dynamic addressing, it doesn't send a DHCP request out initially. It actually sends out a router solicitation message. And a router, if one is present, will reply with a router advertisement message. Now, when we've spoken of ARP before, of course, that is replaced by neighbor solicitation and neighbor advertisements. But also, I think last chapter we spoke about DAD, or duplicate address detection, and that is another use for neighbor solicitation. You're actually trying to solicit someone with the same address as yourself, and so if no one replies with an advertisement, well, you know you're the only one using that address. So that's another part of neighbor solicitation. So ICMP version 6 neighbor discovery also includes a redirect message, which has a similar function to a redirect message in ICMP version 4. And so that's about, sometimes you might have a subnet with more than one router. And so, of course, when you configure a host, there's only one spot for default gateway. And so if there's more than one router, the default gateway can actually send you a redirect message and say, for this particular destination network, use this other device as your gateway. And so that's what the redirect message is about. Okay, so router advertisement messages are sent by IPv6 enabled routers every 200 seconds to provide addressing information to IPv6 enabled hosts. The RA message can include addressing information such as the prefix, the network prefix address, the prefix length, DNS address, and domain name. A host using stateless address auto configuration will set its default gateway to the link local address of the router that sent the router advertisement. And I think I demoed that last time as well. An IPv6 enabled router will also send out a router advertisement in response to a router solicitation. In the figure, PC1 sends a router solicitation message to determine how to receive its IPv6 information dynamically. And so, of course, the reply to a router solicitation is the router advertisement. And so basically the process is, hi, I just booted up. Is there an IPv6 router on the network? I need to know how to get my IPv6 information. And so the router replies with, hi, all IPv6 enabled devices, I'm router 1, and you can use SLAAC to create an IPv6 global unicast address. The network prefix is X, and the prefix length is 64 bits. By the way, use my link local address of FE80::1 as your gateway. And so that's the kind of message you get. And so a device assigned a global IPv6 unicast or link local address may perform duplicate address detection, or DAD, to ensure that the IPv6 address is unique. To check the uniqueness of an address, the device will send a neighbor solicitation with its own IPv6 as the target IPv6 address. If another device on the network has this address, it will respond with a neighbor advertisement message notifying to the sending device that that address is in use. That is not a requirement, but RFC 4861 recommends that that is performed for unicast addresses, just to, again, save duplicate addresses. Okay, so more ICMP messages. So to determine the MAC address for a destination, the device will send a neighbor solicitation message to the solicited node address. And so the message will include the known target IPv6 address, and the device that has the targeted IPv6 address will respond with the neighbor advertisement message containing its MAC address. And so basically this is what ARP was for IPv4. This neighbor solicitation is, of course, what happens in IPv6. Okay, so ping and traceroute tests. So ping is a command that's used in both IPv4 and IPv6. It's a testing utility that uses ICMP echo request and echo reply messages to test connectivity between hosts and provides a summary that includes the success rate and average round-trip time to the destination. If a reply is not received within the timeout, the ping provides a message indicating that a response was not received. It is common for the first ping to time out if address resolution protocol, be that ARP or neighbor discovery, needs to be performed, but normally subsequent messages will succeed. And so that's what this example up the top here is saying, is the first one failed just because we didn't know the MAC address of the destination. But if you do it a second time, you'll probably get all 5. And of course, this is an example of IPv6 ping as well. Now, you can ping the loopback address. And so if you remember from chapter 11, we use 127.0.0.1 as the loopback address. And so that will test the internal configuration of IPv4 or IPv6. And so if the ping does successfully respond to itself, you can see that IP is working on your host. An error message indicates that the TCP/IP stack is not operational on the host. And so, of course, we're showing ping 127.0.0.1, but also if you wanted to test IPv6, you could do ping : 1. Remember, that is the loopback address for IPv6. Now, I've got to admit, I don't actually ping the loopback interface all that often because I've never had it fail on me. Maybe I'm lucky, but yeah, it's never failed on me. So, but pinging the default gateway, that's probably my first check I do when I've got some kind of connectivity problem. Can I talk to my router? Isn't it a valid question that you would want to answer if you've got problems? And so the ping command can be used to test the ability of a host to communicate on the local network. The default gateway address is most often used because the router is normally always operational. So a successful ping to the default gateway indicates that the host and the router interface serving as a default gateway are both operational on the local network. If the default gateway address does not respond, a ping can be sent to the IP address of another host on the local network that is known to be operational. So yeah, if the router's down, well, you're not going to be talking to any other networks, but of course you can ping another host if there is another host to actually see if the actual local network is working. Now, of course, pinging a remote host is a way to test the ability of a local host to communicate across an internetwork. So a local host can ping a host on a remote network. A successful ping across the internetwork confirms communication on the local network as well. Many network administrators limit or prohibit the entry of ICMP messages. Therefore, a lack of a ping response could be due to those security restrictions. And so if, I think, did I demo pinging Microsoft.com in this subject? I think I did, and I think it failed because I think they were blocking ICMP. So I pinged Cisco.com and it worked nicely. So they weren't blocking ICMP. Okay, so Traceroute. Now, I have mentioned it before. Now, Tracert, of course, is the Microsoft command for Windows. Traceroute is the command in iOS, but of course you can abbreviate that. And so it's a utility that is used to test the path between two hosts and provide a list of hops that were successfully reached along the path. So Traceroute provides a round-trip time for each hop along the path and indicates if the hop fails to respond with an asterisk. And so the information can be used to locate a problematic router in the path or indicate the router is configured not to reply. Traceroute makes use of a function of the TTL field in IPv4 or the hop limit field in IPv6, along with ICMP time exceeded messages. And so, of course, basically, it would set the TTL field to 1, and then the gateway will actually, your gateway will then reject the message and send you a time exceeded message back. And so then, of course, it'll just up the TTL field to 2. It'll get through your first router, and then when it hits the second router, it will run out because the TTL field and hop limit field is decreased by 1 with every router it goes through. And so that's basically how you find out each hop along the way. Now, of course, this is a Cisco version of Traceroute. With Microsoft, it also does a reverse DNS lookup. And so it will know the IP address that's responded to it. It will actually then try and do a reverse DNS lookup to see if it can get a host name for that IP address as well. And so sometimes it will, sometimes it won't. And so, as it said, you get an asterisk when there was unsuccessful. Now, if you might actually get a line where this particular router here might actually be blocking ICMP or not responding to ICMP messages. So you might get 3 stars there saying unsuccessful. If the next line actually does work and you get times, well, you know that previous one was just the router. But if you get star after star after star after star for hop numbers as they grow, that probably indicates that you've got a fault on the network somewhere. And so basically I'd be looking at the last successful address and start fault finding from there. That's basically, that's the beauty of Traceroute, is ping will tell you there's a problem, but it doesn't actually tell you where there's a problem. It just says, yes, there's a problem. You can't talk to that host. While Traceroute will actually help you localize roughly where the problem is. And so that's the beauty of Traceroute. But of course, it is a lot slower. So pinging first up, if it works, great. Well, that's not a problem. If there is a problem, it must be somewhere else. But if ping doesn't work, next thing you'd probably do is Traceroute. How far can I get? And so that's good information that you can use to help fault find. Okay, so the first message sent from a Traceroute will have a TTL field value of 1. This causes the TTL value to reduce to 0, because the first router, of course, will decrease it by 1, and then it will, of course, respond with a time exceeded message. And so basically each time it will up the TTL count by 1, and so it will just get 1 router further each time. And so, of course, the source address of this time exceeded message is how you know what router you've been through. And so that's how the host figures it out. So the TTL field continues to be increased until the destination is reached, or it hits a predefined maximum number of hops. So I think often if you do Traceroute, it says it's going to go through a maximum of 32 hops or something, I think, from memory on Windows. Unless I'm thinking of an old version. Anyway, so that's the end of the chapter, just a bit of a summary. So the purpose of ICMP messages is to provide feedback about issues related to processing of IP packets under certain conditions. ICMP messages common to both version 4 and version 6 are host reachability, destination and service unreachable, and time exceeded. The messages between an IPv6 router and IPv6 device, including dynamic host allocation, address allocation, for router solicitation and router advertisements. The messages between IPv6 devices include a redirect, as well as neighbor solicitation and neighbor advertisements. Ping can be used for both v4 and v6, and so it sends an echo request. The destination will send an echo reply that will hopefully get back to you. Ping can be used to test the internal configuration of IPv4 and IPv6 on a local host, while Traceroute generates a list of hops that were successfully reached along the path. There's the logo. So that's chapter 13 finished. And so we'll get on to chapter 14 next, which of course is TCP.